take it back to you, Chair of the session. Thank you for listening to me.
Thank you, Engineer Karen, for those comments, really wide-ranging, from the capacity of professionals who are going to help us look after this infrastructure through to how we can be able to improve the standards for the construction of the said infrastructure. So go back to our topic, and this section we are discussing is a climate risk assessment. So back to you, Faith, so that you can give us your comments on these adverse weather issues, what could go wrong, and how do we prepare for that, especially now that we just came through an adverse weather period from I think somewhere mid last year, when we have been anticipating El Nino. It happened in full scale, but still we had some adverse weather. Karibu.
Thank you once again. Adverse weather is taking place, and just like the former speaker said, I believe we can take advantage of it and make it work for us. So looking back, when we had heavy falls, and eventually the El Nino was not what it was meant to be, but it came anyway. So in Kenya Power, what we did, we, just like our engineer here has alluded, we took in time to audit, investigate our vulnerabilities, and we indeed found several areas of vulnerabilities that could, if El Nino could have come as it was meant to be, unless we did something, we would be found unawares and would lose a large amount of our assets and eventually disrupt the life of Kenyans. So we went with fast actions to put up teams, both internal and external teams, to restore what could probably, if left like that, fail. For instance, in substations, we had places where we didn't have good drainage, so we had contractors come in and redo the drainages and do the drainages that are not existent, and also do walls, and improved, like engineer here noted, on the transmission and the distribution lines. And we also, for MEA's protection, we took action in making sure that in the event that a fault occurs, how quick are the protection relays able to find the fault, clear it, and restore power to the unaffected areas as soon as possible. And so we had to change several relays that were old and electromechanical to the numerical relays, and we're still continuing to do that, because I know if you're not able to have data, if you're not able to catch the faults before they happen, and that is only possible with the use of the smart technologies. By good luck, before even the El Ninos were mentioned, we were preparing to revamp our network, which has been aging, and especially on the protection side and even the distribution side. But I think Kenya Power is doing a great job, because not only are we preparing because of El Nino, but we've been preparing because of a long-term plan to be able to allow not only our network to be all over the country, but also to be reliable. So we have a big challenge, but we are able to meet the demands that come with it. But the climate change, especially with increase in temperatures like now we don't have much rain, so it means our hydros will be affected. So what we do with the high temperatures, probably we would want several people to install solar systems. But even so, after they install solar systems, what happens at night? Unless they put up storage systems, then we'll not have that solar helping us at night. So it's a mix of the input from various people that are in the system and that are out there, so that we'll have not only saying the temperatures are high, but work with those temperatures during the day and also possibly store it and us have the same power work for us at night, now that the hydros are going down. but it's a mix, so we should be going towards generation mix. Generation mix will solve our problems, whether El Nino is here or it's not here. It's either the water or the lack of water. So we want to have a balance throughout the country where we have the climate working for us. The winds, the water, the sun, the geothermal, and every other thing that comes from nature should be able to be mixed in such a way that it helps us solve our demand, but also go to a place where we have a resilient network, so that we don't just have disruptions as they come, but we have already anticipated if they come, what will we do? So there is a lot to speak in line with even connecting our lines, so we have interconnectedness, so that when one area has a challenge with generation, the other area can still supply it, but it's a big discussion. But I can promise you that as a company, we are up to the task, and we are doing all that we can do in collaboration with KETRACO and KenGen. Thank you.
Thank you very much. Maybe I can just proceed. Comment on the subject on the we are currently discussing. And I wish to point out that in terms of management and risk identification related to climate change, then these early warning, these anticipations are going to be very important for us. And I appreciate what the weatherman did for the country. It's always better to say there is an elephant in the room, and that people will sometimes prepare, rather than underestimate the issue, and then people are not ready, and then they are caught off guard. For me, just looking at the conflict areas where we probably most of the time have our projects, is that yes, there were effects. I think most of those areas, the way they're structured, then we have a situation whereby they suffer from the two extremes of the weather. When it's hot, it's too hot. When then it rains, we have flash floods, and it's low-lying land. The water doesn't move very well, and it can move in any direction. So then what you realize, if you are building energy infrastructure there, and you have mini grids, you have diesel stations which are basically supplying those areas, they are susceptible to flooding. So those are things which need to be identified and early during the actual design of the project, so that you can more or less climate proof some of those infrastructure. But I think in terms of probably the industry, the way it is, the energy sector industry, in terms of identifying, managing climate risk, I think at some point there are proposals even to have a weather station focused on the energy, because then we are beginning also to have resources which you can take advantage of, and which of course also need focusing. For example, wind, solar. If you're going to be able to harness some of those resources properly, we will need to be able to focus in a day, in a week, so that the energy planners can also take advantage of that. So those are some of the things also we, as an industry, as a sector, we can also consider. Specialized weather focusing systems for the energy sector, and it will help us manage some of these climate risks. So allow me to return it to the moderator, so that then he can guide us further from here. Thank you.
Thank you, Engineer Kimeu. Thank you all the panelists for those insightful comments on the risk assessment. I think we've gone through a number of issues. We have the direct risks that the weather will pose to the infrastructure, say if it will be a case of flooding, or say if there are any other disruptions, maybe because of the weather on the transmission systems, creating faults in the system. We also have issues that will probably lead to maybe resource availability or lack of thereof, and so we have the direct risks, and we have also dealt into a number of things that are related to how we have laid out our infrastructure across the country. I think just to add to what our panelists have said, I think from a generation perspective, we have different generation modes. You talk of geothermal, I think that's one of the generation modes that we have had a lot of limelight in the recent past. But we also know that we are dependent on the hydro, like Engineer Faith said, and there are chances that when we have this quote-unquote adverse weather or increased precipitation, it can end up as a blessing, say, for the hydros, because we get more rain, we get our dams full, even though they can also come with risks because it can cause flooding downstream, which can affect other people. But even in the adverse situation, say, when the dams are filling up, if you don't have proper protection, where you're going to allow safe spilling of the dams, then the dam walls can be breached. And I don't think anyone wants to imagine what will probably happen if we had one of our dams wall caving away, and then we have flooding from the dams, because the kind of flooding that we experience normally when the dams spill, that's a very controlled way. In fact, the dams help us to avoid the spilling in the first place by containing the water for a reasonable period of time, and then being able to release it either in a controlled way through generation, or in some cases where we allow spilling. But if it was to happen that we are not able to control that, and now the dam spilling has to happen, say, by way of breaching of the wall, that can be very catastrophic. But at the same time, you're saying when we don't have enough rains, then we also get into another challenge, because now we don't have the resource to be able to generate with. Many people may look at geothermal, for example, and imagine quote-unquote is immune from weather. Yes, the resource itself is not directly recharged by rainfall, so we expect a sustainable generation from that. However, I have no experience with geothermal resources in other countries, but what we have in Kenya, and especially in Ontario, the kind of soils we have, they are called loose volcanic ash soils. So if we say had floodlights, there's a possibility, say, for a whole well pad, and a well pad is the point where you have several wells connected to be able to supply steam, being swept away because the soils are quite loose. And that will mean a loss of generation. And just to put in perspective, a well pad can have maybe 2, even up to 5 wells on one well pad. Each one of those wells will cost approximately 700 million Kenyan shillings to drill. So you can do your maths. If you have one of them washed away, how much time, how much resource will it take for us to be able to restore that well pad and restore generation to where we need to have it? And so those are the kind of things that we are talking about when we talk about the risks that we have on this. Now, with those comments, I think we can now move on into the design bit. We have had our parents allude to that, but how, as a country, can we be able to lay out our generation, transmission and distribution infrastructure to be able to benefit from the climate mix? And as a country, there are places where we have highlands, where we have sustained rainfall. We have places where we have almost desert conditions. So how can we be able to set out our infrastructure to be able to, number one, benefit, say, from the issues of generation mix, where we take advantage of the resources with regards to the weather patterns, and that will have to do with the generation, distribution and transmission systems, and that is will have to do with, say, where we have a situation where we have a common grid, and so one thing affecting the grid one side can be able to affect the whole of it. At times you can end up with a national blackout across. But then we also have proposals that are coming up like distributed generation, like what engineer Kimeo has talked about, maybe the issue of distributed generation, mini grids that are integrated or those kind of things. And then also we have talked about the issues of being able to use information to predict specific to the generation systems, and probably we will be looking at things like IoT to be able to help in this resilience. So, thanks for your comments. Maybe I can take the opportunity to see if I can give the first 2 or 3 minutes to Engineer Okere if he's available before I come back to the panel in house. Engineer Okere, are you able to speak at this point?